Hello wonderful person, this is Anton, and today we're going to discuss something a little bit different. The famous Infinite Monkey Theorem, a hypothetical proposition that basically states that given enough time and given enough monkeys, by hitting keys at random on a typewriter, at some point we're going to end up with complete works of William Shakespeare. Or basically here this is a kind of a thought experiment that involves tremendously large numbers in terms of probability, where a bunch of monkeys or a bunch of chimps try to randomly hit keys and eventually produce something that actually makes sense. But they do this completely by accident. And specifically, we're actually going to be discussing a super recent paper that crunched the numbers and concluded that when it comes to Finite Monkey Theorem, or basically when you actually include real chimps, real typewriters, and real universe, it seems to be still impossible. And so let's discuss this in a little bit more detail, starting with a bit of a history. And here we start with this guy, Émile Borel, a French mathematician who proposed this as a mathematical concept back in 1913. In one of his books on probability, he proposed a thought experiment involving monkeys and various statistical ideas, where he tried to illustrate that given enough time, anything can be possible. But it was actually the famous Arthur Eddington, the same guy that made Einstein famous, that eventually connected this to something we now refer to as statistical mechanics. This is actually related to the 2024 Nobel Prize in Physics that you can learn more about in one of the videos in the description. And so in his book, The Nature of the Physical World, Eddington writes, "If I let my fingers wander idly over the keys of a typewriter, it might happen that my screed made an intelligible sentence. And if an army of monkeys was strumming on typewriters, they might write all the books in the British Museum. But the chance of their doing so is decidedly more favorable than the chance of the molecules returning to one half of the vessel." In other words, he said it's possible, just extremely unlikely. But I guess much more intriguingly, approximately 2 decades ago, someone actually tried this as a kind of an experiment / art project. And you can read about this in some of the older articles from BBC in the description below. And so here the students from University of Plymouth decided to literally do this as an experiment using real monkeys. They used these cool-looking guys, Celebes crested macaques, and put them in the enclosure while also giving them a computer keyboard, and then basically let them play for approximately 6 weeks. And the results were maybe not exactly promising. In total, all of the monkeys produced just 5 pages, and mostly consisting of letter S. But the lead male decided to do something a little bit more drastic. He used the rock and started smashing the keyboard because, why not? He's a monkey. And while observing this, a lot of his monkey friends decided to join in and basically peed and pooped on the keyboard just for funsies as well. And so the result of the experiment was basically a bunch of broken keyboards covered in pee and poop and 5 pages of letter S written over and over. No Shakespeare. With the conclusion from this whole study / performance being that monkeys are not really random generators. They do possess complex behavior, but they're maybe not very interested in screens and keyboards. But in this recent study, Stephen Woodcock and Jay Falletta decided to do something a little bit different and something maybe a little bit less practical. Instead of infinite monkeys and infinite time, they decided to perform an analysis of a more finite version of this theorem in order to determine if it's possible at all. And the main question was really simple. What's the probability that, given a string of letters on a very simplified version of a typewriter, a certain number of monkeys would be able to type anything either during their lifespan or even during the entire period while the universe still exists? Here we're talking about a period of approximately Google years, 10 to the power of 100 years. And so basically the question is, are they going to end up with all of the books in the world, or is it still going to be impossible to produce anything? And so here we had a typewriter with 30 keys, containing English letters and punctuation marks, and we had anywhere from 1 chimp to possibly 200,000 chimps, which is the approximate number of all chimps on the entire planet. And they were all typing 1 keystroke per second for anywhere between their own lifetime all the way to the end of the universe. You can actually learn about this end of the universe concept in one of the videos in the description. And well, strangely enough, a single chimp was actually able to produce something during its lifetime with approximately 5% chance they could eventually type out the word bananas. They could possibly type it out within approximately 30 years. And if you actually want to know how many times they would have to type something, the expected number of keystrokes for the word bananas, and that's basically to produce it completely by accident, is approximately 22 billion times. But if we expect them to produce a short sentence, such as I chimp, therefore I am, here the chances drop dramatically. They will definitely be able to produce it before the end of the universe, but they will not be able to produce it before the death of all chimps on Earth. Here the chance is 2 times 10 to the power of minus 20. A ridiculously tiny chance. And naturally, anything else more complex becomes ridiculously more unlikely to be produced. So for example, in order to reproduce a simple children's story containing 1800 words, such as The Curious George, a fictional story by Margaret and H.A. Ray, we would not have enough monkeys and would not have enough universe time to get even remotely close to what we need, which is 1800 words. And that means that the reproduction of anything larger becomes practically impossible. Here we actually have 2 more examples. Planet of the Apes, which is 83,000 words, with the probability of occurrence before the end of the universe being this small, which is a really small number. And in order to get the entire works of William Shakespeare, which is approximately 885,000 words, we will have to deal with 0 followed by 7.5 million zeros in terms of probability. Although here all of this is a little bit easier to visualize on a logarithmic graph, with the left side actually showing us the number of universe deaths measured in Google years. And though obviously probability would go up if there are more monkeys or if they can type faster, here no matter what we change, when it comes to the Finite Monkey Theorem, the conclusion is basically still the same. Just like a lot of other paradoxes and a lot of other probability puzzles, such as Zeno's paradox or Ross-Littlewood paradox, the results just don't match up when we consider the constraints in the actual universe. It might make sense theoretically, but it makes absolutely no sense in the actual physical world. And so no matter how many monkeys we have, no matter how fast they type, and no matter how long the universe survives, we're still unlikely to get Shakespeare before the universe ends. Although, as a side note / fun fact, if you're using Windows, turns out there's an app called Monkey Typewriter that basically allows you to simulate all of this. In other words, here, you can pretend that you have monkeys working on typewriters, generating random words. And even if you leave your computer on for a long time with super fast monkeys typing everything, you're unlikely to end up with anything super interesting anytime soon. But why is any of this even important? Well, here this also kind of connects to the paradox when it comes to the origins of life. Because unlike monkeys typing random letters on keyboards, we know for a fact that DNA, which can also be represented as letters, is way more complex than the works of Shakespeare. Yet somehow, in just the right conditions, given enough time, certain types of molecules end up forming certain types of structures. And that paradox does not have an answer yet. But that's actually why it's maybe important to understand how this works, why this works, and how these unusual theoretical concepts can then be used to understand physical concepts in realms like biology. So for example, fields like proteomics that try to understand how proteins can fold even though there's a lot of random chance involved, or even connecting all of this to the famous idea known as the RNA world, how complex life potentially formed from simple RNA molecules which were all basically shuffled and mixed around randomly until something complex was created in the process. And so in some sense, all of this could potentially help us explain why we exist as well. But we obviously just have no answers yet. But basically this was just a really intriguing and somewhat amusing study that once again shows us that when it comes to probabilities, we kind of underestimate how unlikely certain things are. And we definitely have trouble imagining big numbers. But at least for now, these are just thought experiments and don't really have any practical use, and might never have any use at all. And so on that note, thank you for watching, subscribe, share this with someone who loves learning about space and sciences, come back tomorrow to learn something else, support this channel on Patreon by joining channel membership or by buying the wonderful person t-shirt you can find in the description. Stay wonderful, I'll see you tomorrow, and as always, bye bye.